Hello, welcome. Let's try to solve another Leetcode problem. 1627 graph connectivity with threshold. So for this problem, we are giving n cities labeled from 1 to n. So two different cities with labels x and y are directly connected by a bidirectional road if and only if x and y share a common divisor strictly greater than some threshold. Yeah, so let's try to understand what is the meaning of this very long sentence. So more formally, cities with labels x and y have a road between them if there exists an integer z such that all of the following are true. So those three formulas are just explains what happens for the description. So maybe you don't understand it, so it's going to be like this. So we're going to find some value x and y. X modulo z going to equal to 0, y modulo z going to equal to 0, and 0 going to be more than the threshold. And then this x and y going to be connected. So this is just the definition. So giving two integers n and the threshold and an array of queries, so we just need to answer each of the queries. So for example, the first query 1 and 4. Is 1 and 4 connected? No, it is not. Is 2 and 5 connected? No, it is not. So it's going to be false. Is 3 and 6 connected? Yes, it is. So we're going to return true. But why? So for 1 and 4, actually we just needed to find the greatest common divisor, GCD, greatest common divisor. So for 1 and 4, it is 1. But 1 is less than threshold. Of course, it's not going to be false. So for 2 and 5, the greatest common divisor is going to be 1. 1 is less than threshold, so it's going to be false. But what about 3 and 6? The greatest common divisor is 3. 3 is more than threshold, so it's going to be true. Yeah, so this is just the idea. Yeah, we're going to check if any two nodes are connected or not, according to the query's threshold and the number of the nodes. Yeah. How can we solve it? If we are going to check if two nodes are connected or not, the easiest way maybe, yeah, it is the unified. So we're going to use the unified to check if two nodes are connected or not. But how can we use unified? Let me just explain. Yeah, so for a node 3 and 6, so what about 2 and 6? Is that connected? No, it is not. Yeah. So we're going to check all the nodes, which is going to be more than the threshold. So currently threshold is 2 in the first example. So we're going to choose all the nodes which is more than threshold. So it's going to be starting from 3. So it's going to be 3, node 4, 5, and 6. And then we're going to choose all other nodes which is going to have a greatest common divisor, which is going to be more than the threshold. It means it's going to be 3, 4, 5, and 6. Both of them is okay. So what's going to be the next number? If we are choosing 3, what's going to be the next number? If we were to have a greatest common divisor which is more than 2. So definitely we're going to choose a 6. So 3 times 2 it is 6. So what about 4? So 4 plus 4 is going to be 8. What about 5? 5 plus 5 it is 10. And for 6 we're going to choose 12. Yeah, so definitely we're going to choose all those numbers. Maybe 3, 6, and 9, 4, 8, and 12. We're going to choose all those numbers. All those numbers have the greatest common divisor, which is going to be more than 2. Because 3 and 6, it is 3. 3 and 9, it is 3. 6 and 9, it is 3. So we're going to connect all those possible cases. So for example, 4, 8, 4, 12, 5, 10, and etc. for all other cases. So after connecting all those cases, yeah, so 3 and 6, we should know. 3 and 9, we should know it should be connected, right? And 4 and 8, it is connected. 5 and 10, 6 and 12, it is connected. So if 6 and 12 connected, what happens? So 6, 4, and 8 are connected. Let me think about it. So for this one, 4, 8, and 12, which going to be connected to each other. Yeah. So what about 4 and 6? So for 4 and 6, the the greatest common divisor is going to be 2, but our threshold is 2. So 4 and 6 should not be connected. Yeah, so let me think about it. So 4 and 8 and 12 gonna be connected. 3, 6, and 9 gonna be connected. This 5 and 10 gonna be connected if we have. If we have a 6, but for this example we don't have yeah, but for this example we don't have 6. So because our node is n equals to 6, it means we have 6 node. Yeah, and it's this. So we're gonna check the node 3, 4, 5. Yeah, let me just start coding. Maybe I can find the reason. Maybe, yeah, why it is like that. Yeah, so I will explain it later. So for example, we have I will explain it later. So maybe we have like 3, 6, and 9, 4, 8, and 12, 5, 10, and 15, and here we have 6 and 12. So here our problem is whether this 6 and 4 should be connected, because if 6 connected is with 12, 12 connected with 8, and 12 connected with 4, so definitely 6 and 4 should be connected. But actually 6 and 4 should not be connected, because if they connected, the great common divisor gonna be 2, but 2 is equal to threshold. Yeah, so we will consider it later, but let's just start programming. We're gonna prepare a class of if. So this is a unified. Let me just quickly finish the template for my unified. So here I'm gonna use so self.parent equal to list of range with and I need to define a file first. It's gonna be self with this node n. So while n not equal to self.parent n, so n gonna equal to self.parent until we find the answer. So we're gonna return n. Yeah, let's define the union. So this is a unified. You can also introduce more code, but actually we don't need at the moment. So for the union, it's gonna be 2 node n1 and n2. So first of all, we're gonna find the parents p1 and p2. It's gonna be self.find n1's parent, and we're gonna find n2's parent, and self.parent p2 gonna equal to p1. So this means p2's parent is gonna be p1. Let me just write another method. I can call it is connected. So it's gonna be 2 node n1 and n2. So we're gonna return self.find n1. We're gonna check if it equal to self.find n2. Yeah. So here we finished our unified. Now let's just try to use it. So I'm gonna call the unified. It's gonna be uf with the number of nodes plus 1. Because actually for the unified, we're gonna use the index. So for example, we're gonna use if n equal to 6, it's gonna be 7. So this means from the index 1 to 6. Yeah, if n equal to n plus 1 equal to 7, so the length of the array is 7. So this is 0. This is just a dummy place. Actually, we just use 1 to 6. So this is why we're gonna use n plus 1. Yeah. Now what are we gonna do? We're gonna check the number of nodes. So for I in range, it's gonna be threshold plus 1. Yeah, because if we were to choose the node, it must be more than the threshold, at least from the first one. So it's going to be threshold plus 1 to n plus 1. We need to choose this node 6. N plus 1 is 7. This means we're going to choose this node 6. For j in range, it's going to be I. Right? Yeah. So it's going to be I, n plus 1, and I. So this means, for example, if I equal to 3, so j gonna equal to 3 first, and then j gonna equal to 6. So we're gonna use f dot union I and j. Yeah, so we're gonna union them together, and then we're gonna check that. We're gonna for AB in queries. We're gonna prepare a result array. Let me put it here. So this is the result array. So the result gonna append uf dot is connected. We're gonna check if it is a true or false. Is connected A and B, and finally we're gonna return the result. Now let me just run it to check if it works. Now as you can see, it works. Yeah, let me just submit it to check. As you can see, it passed for all testing cases, but it is not so fast. Maybe from the file we can speed up a little bit. So from here, we're going to use the self.parent n, going to equal to self.parent with the self.parent n. So from here, we can speed up for the union file. Yeah. So basically, from the beginning, it is just find its parents and find its parents. So for example, we have an array, and we're gonna find its parents, but this is just a speed up. This is like a shortcut, so it's gonna be much faster. Let me just submit it. Yeah, now as you can see, it is much faster than before, because from the find union find, from the find, we're gonna speed up from the this line of code. Yeah, I hope you understand it. Now let's just analyze why we're gonna use such kind of code. Yeah, so in my example, actually it didn't work, but why it works? So for here, this I is in range threshold plus 1. So it means I gonna be start from 3, 4, 5, and 6, right? And for j gonna equal to, if I equal to 3, so j gonna equal to 3, 6, because j cannot equal to 9. So this means 3 and 3 are going to be connected, 3 and 6 are going to be connected. So this means 3 and 6 are going to be true, because it is connected, right? What about this number 4? 4 is going to be 8, but can we choose 8? No, we cannot choose 8, because we only have the number of nodes, it is 6. So we will ignore it. Yeah, so we will just ignore it. If we have such kind of nodes, maybe all those nodes, it is possible, but we don't have these nodes. Yeah, so that means it is not possible, right? So what about the 10? We don't have such nodes, it is not possible. So what about the 12? We don't have the nodes, so it is not possible. This means 4 and 6 would never be connected, because we don't have 8 and we don't have 12. Yeah, but what happens if the number of the nodes equals to 12? If the number of nodes equal to 12, so it's going to be totally different. Yeah, so it is dependent on the number of nodes. You see, this is a very strict problem, and we have to analyze it carefully. If the number of nodes equal to 12, let's just go back. This means we're going to have 8 and 12. From here, we have 10. And from here, we have 12. So this means 6 and 12 are going to be connected. 4, 8, 12 are going to be connected. But for queries like 4 and 6, yeah, but for queries 4 and 6, it's gonna be connected according to uh, yeah, according to the unified, because 6 and 12 are gonna be connected, 12 and 8 are gonna be connected, but this 4 and 6 should be connected. Actually, it should not be connected. Yeah, maybe there's something wrong with the problem. I don't know. This is just yeah, something I never think about it before, and now we have such kind of cases. I don't know. Yeah, I think anyway, this problem is just testing us the unified and the greatest common divisor. I think that's all about it. Thanks for watching. See you next.